Okay, so the outcome here is to look at how reflections and their functions, reflections in both axes and actually in a diagonal line, how the graphs are related to the equations. So the first thing you're going to look at is if you start with f of x and you look at what's happening here. If we're thinking of the replacing model, to get the function to look like this, you're actually replacing y with minus y. Right? Because that's the same as, if I have a minus on this side, like if I say that minus x equals 8, x is equal to minus 8, right? You can have a negative sign on either side. So you could say negative y equals f of x, or you could say y equals negative f of x. This could be outside of the function on that side, or it could be on the side with the y. The advantage to this is, I will tell you up front because it's not really discovering it, this is going to be a change on the y values because it's outside of the function, just like the translations were. When we look ahead here a bit, the other thing we're looking at is changing y equals f of x to putting the negative inside. You didn't do that one last year. You did the previous one last year, but you didn't do this one last year. And the reason being is because if you think of a parabola, if you reflect it one way, it definitely looks different. If I was to reflect it horizontally, what does it look like? What happens? It's exactly the same if you reflect that horizontally. I mean, not my crummy picture here, but if you have the actual right thing. But we're not talking about just parabolas. We're looking at any kind of a function. So this is why, and I don't think I picked a good function here because it's hard to see where a line, how you're reflecting a line. Now, let's look on the graphing things here to see what's happening. If you replace, I was asked you a million times if you really, did you really mean it when you say yes? Are you sure you want to say yes to opening that? Okay, so here's a function, f of x. It's actually square root of x, but we'll just call it f of x. If we are going to reflect it over, so this is what we're looking at. We're looking at changing f of x to f of minus x, or to changing it to minus y equals f of x, which you could also write that way. We're going to look at the vertical reflection first here. Okay? There's the vertical reflection. Okay? I'm pretty sure you're okay with the concept of reflecting. The vertical reflection is called minus y equals f of x, or y equals minus f of x. If you have a point that is here, where did that point go? When I reflected it, where did the point go? Down here, right? That became that point. This point here became that point. What changed about those? If I was to put this on here, actually, you know what I should do instead is just see this over here. Let's, not because I want you to see, you know what, that's a bad idea. Let's instead just look at the coordinates of the points here. Show label. No, show properties. We could pause this. What changed there? This point, yeah, this point was 4, 2. Now it's 4, negative 2. X coordinates the same. Y coordinates opposite. This one the same thing here. This is 1, 1. This is 1, negative 1. Okay? If I was to move this so that it was a different function to start with, the reflection is like that now, right? Like let's put it in the middle like that. It's hard to see here with all my things written down here, but this point, which looks like is 1 and negative 0.58, it was on the negative side. Where did it go when it reflected? Well, it's positive, right? Putting a negative in front doesn't make things negative. It changes their sign, right? So if the y-coordinate was already negative, it becomes positive. Right? This point up that was positive 4.8 is now negative 4.8. This point that's negative 0.58 is now positive 0.58. So let's look at a different function here instead. Different starting function. There's a different starting function, except I got all my goofy points here again. Oh, that's really good. Where is that going to reflect if I reflect it vertically? Where is that going to end up? It's going to end up underneath. Okay? You think so? So let's look at this. Reflect function number 2. Did I call that? Oh, that's bad. Wrong one. Reflected over, I did it backwards. That's over the x-axis. I got mine backwards here. Oh, x-axis, y-axis. It's reflected across there. Any point that I put on here, this point has gone to there. The y-coordinates changed. Okay? Let's go back to the original here without that. Okay, if I do this now, though, if I put this... Oh, it's not going to let me do that. If I put this here to start with, where's the function going to be when I reflect it? Think about it for a second and discuss with somebody, because people tend to find this difficult. I will get rid of all these stray points. Where's it going to be? Because I think you get misled by what you learned in grade 11, even though you were doing the correct thing in grade 11. If I replace y with negative y there, where's that point going to go? It's going to go to 3, 1. It's going to go there. It's not going to be reflecting over this vertex. And I think from grade 11, with working with parabolas, you think about reflecting around the vertex. If this is the original function and I reflect it, I replace y with negative y, it's going to be... It's going to be there, right? That's a reflection across that axis. If I give you a starting function and you replace y with negative y, every point changes. This point goes here. A point that's below is going to go about there somewhere. You switch every y coordinate, and that gives you your reflected function. Now, something you, again, as I said, you didn't do in grade 11 was you reflect things horizontally. What's that going to look like if I reflect it horizontally? And again, I have these backwards. This should say reflect over y-axis. If I reflect that over the y-axis, what's it going to look like? It's going to look like, oh boy. Looks like that, right? That's a reflection across the y-axis. The equation of that's actually f of negative x. If I had a relationship here where this was a point on the original function, if putting whatever that is, what are the coordinates of that? 1, 1. If putting 1.04, I guess. If putting that value in the original function works, then what's going to change over here? Which of those numbers? X, this is going to be negative 1. If originally putting a 1 in this f of x, if I subbed in a 1, I'm really having a hard time switching those back and forth. If I put in a 1 in for x, this function f of x turns it into a 1.04, because I kind of missed, I guess. If I put it on this side, if I put a negative in there, I got to start with a negative number to get that same relationship. Okay? We're looking at two different kinds of reflections here. Now, I have asked you to go through and work with some tables of values and stuff. This really, I don't want you to spend a lot of time on it because I really think you already get this part. And if you think you get that part already, please notice though that the way we're looking at it here, you have to think about sort of inside and outside of the function. X squared, you write like that, but you probably should think about it like this with brackets, because then there's clearly an inside and an outside of the function. If you didn't want to write that with a squared, you just wanted to talk about a function in general, you could, instead of the something squared, you could just say, I'm going to call that f of x. And the squared, you're going to use the letter f to represent that. That's all that means. I'm not sure how comfortable you were with function notation when you first learned it, but when you say there's two functions, f of x and g of x, you're just using those letters to represent some collection or maybe a simple thing. The half circle that I showed you was y equals square root of 4 minus x squared. That's a lot of ugly stuff, all of this. you could just say, I'm going to use